Welcome to day 9 of our Explainer series. Today, we're tackling a massive misconception in software engineering right now. You see it in headlines, you hear it in boardrooms. It's this belief that the future of artificial intelligence relies on building one massive, all-knowing, autonomous model that does absolutely everything for us. We hear this narrative constantly, right? The godlike agent. But honestly, that's just not the reality. Even the absolute most advanced large language models are hitting a wall. They're heavily limited by fixed, programmatic workflows. So we aren't actually moving toward a single omnipotent model. Instead, we're moving towards systems of multiple, highly specialized agents working together.
But naturally, that shift raises a really serious engineering problem. How do you actually get these different specialized AI agents to collaborate effectively? And more importantly, how do you do it without creating this brittle, tangled mess of direct API calls? Well, by the end of this explainer, you're going to understand exactly why event-driven architecture is the absolute only sustainable way to scale multi-agent systems.
Okay, before we even look at any code, let's build some intuition. Imagine a bustling, high-end restaurant kitchen. You've got 3 main stations: the grill, the prep station, and plating. This kitchen actually perfectly illustrates the critical difference between tightly coupled and loosely coupled software. It's a fundamental distinction that will literally make or break your system architecture.
Think about it. If we design this kitchen using a tightly coupled, synchronous model, it's a disaster. The grill chef finishes cooking a steak, walks over to the prep chef, and physically stands there waiting for the side dishes to be done before handing everything over to plating. What happens if the prep chef drops a pan? Well, the grill chef is stuck waiting. Plating is stuck waiting. Throughput absolutely plummets, and the entire kitchen grinds to a halt. This is exactly what happens when you connect AI agents with direct, synchronous RPC or API calls. While one agent waits for a response, your highly expensive compute is just sitting there idle. Now, let's look at the alternative. This is how a real, efficient kitchen actually works. They use an asynchronous ticket rail. A ticket goes up on that central rail. The grill chef cooks the steak, puts it on the pass, and just updates the ticket. The prep chef does their job completely independently, pulling from that exact same ticket. This is loose coupling. Nobody is just standing around idly waiting. They simply push and pull updates as they work. It's incredibly fast, it's resilient, and most importantly, it scales. So, bringing this right back to software, as Dharmesh Shah noted, agents are essentially the new apps. You can think of AI agents as autonomous microservices. But unlike your traditional microservices, they have some really deep, complex informational dependencies. They need context, they actively use external tools, and they have to share their reasoning with the rest of the system. Because of that complexity, if you design a system with hard-coded dependencies between these agents, say Agent A directly calls Agent B, which directly calls Agent C, you are basically building a house of cards. If just one single agent crashes or hallucinates or hits an API rate limit, the entire chain shatters. You've created a single point of failure that is nearly impossible to debug at scale. And trust me, in production, debugging a tangled web of synchronous AI calls is a nightmare you definitely want to avoid.
So what's the fix? The solution to this fragility is event-driven architecture, or EDA. Think of EDA as the central nervous system for your software. By using an event streaming platform, something like Apache Kafka, for example, your decoupled components communicate asynchronously. They don't ever talk directly to each other. Instead, they produce and consume events through a central persistent log, just like that ticket rail in the kitchen.
Let's step through the exact high-level flow here. First, Agent A processes its specific context and finishes its task. Now, notice it does not call Agent B. Instead, it simply publishes an event to the stream, maybe something like customer data extracted. The event stream securely holds that data. Then, Agents B and C, which are actively subscribed to that stream, consume the event asynchronously. They grab it only when they are fully ready to process it. They act completely independently. They share all the necessary context, but they never, ever force another part of the system to wait. Let's ground this in a real-world enterprise workflow to see why this really matters. Imagine a customer emails you requesting a refund. A specialized support agent analyzes that email and updates your CRM. But instead of triggering a fragile cascade of API calls, it just broadcasts an event. Instantly, a completely separate billing agent sees this event and processes the transaction. At the exact same time, an auditing agent reads that same event and securely logs the action for governance. Everybody does their job, zero bottlenecks. If you're a practitioner looking to actually put AI agents into production, adopting this architectural shift is pretty much non-negotiable. Event-driven architecture gives you horizontal scalability. You can literally add 10 new specialized agents tomorrow without breaking your existing systems. It gives you low latency for real-time adaptation. And crucially, because every single action is written to a persistent log, you get built-in governance. You have a perfect time-stamped audit trail ready for human-in-the-loop oversight.
So, to wrap this all up, moving away from fixed programmatic workflows to dynamic event-driven architectures is absolutely the only sustainable way to scale your AI systems. The future of AI isn't a single giant brain in the sky. The future is dynamic event-driven orchestration.
We are officially leaving the era of passive software and entering an era of collaborative, autonomous systems. So, the one key takeaway I want to leave you with today is to look at your current stack right now and ask yourself, is your infrastructure actually ready to handle the event-driven, multi-agent future?